Hello class, this is an explanation for homework 5, which is based on a 0.5 millimeter diameter sand particle and a temperature of 5 degrees centigrade. The video that was an example 7.1 has a couple of issues, so we're going to go through that information again. The first step that you'll have in this homework assignment is to calculate the initial estimate of the settling velocity based on the diameter of the particle, the viscosity of the liquid, and the density difference of the solid and the liquid. After that, you'll calculate the Reynolds number, and from the Reynolds number, you will calculate the drag coefficient based on this equation. So, using the drag coefficient, you can calculate a new estimate of the settling velocity based on the difference in the solid and liquid densities, the diameter of the particle, and the drag coefficient. So there's a lot of ways to do this problem. It's probably easier to do it with a pencil and paper. But if you use a spreadsheet, then you have to get your cells locked down, which is kind of a pain, but then it's useful. So getting the densities in, we make the initial settling velocity estimate of 0.037 meters per second, ending up with a Reynolds number of 7.9 and a drag coefficient of about 4.5. Taking that drag coefficient into equation 7.8 gives us a new estimate of the settling velocity of 0.031 meters per second, and a slightly lower value of the Reynolds number and a slightly higher value of the drag coefficient. Repeating that, the settling velocity is 0.029. Again, lower Reynolds number, higher drag coefficient, and so on, till we get down after only 1, 2, 3, 4, 5, 6 iterations of a settling velocity of 0.027 meters per second. Under these conditions in the problem of example 1, and you can see that the Reynolds number is converging and the drag coefficient is converging. So I hope this is helpful for you for doing the homework problem number 5. If you have any questions, please let me know. Thank you.